Uh, Last class we have started with the storage management. Okay, in storage management, the first one is the file system management. Usually, the files usually organized into directories. Okay, and access control on the most system to determine who can access what. That access control will be managed here by the file system management. And here the in file system management, the OS activities are creating, deleting the files and directories. Creating the files, deleting the files, and directories also. Creating directories, deleting directories. This is the operating system's activity. And primitive to manipulate the files and directories. This is also the operating system activities. And mapping files onto secondary storage, that is also operating system's responsibility. Okay, mapping files into the secondary storage and backup files onto stable storage media like non-volatile storage media, backing up of the files. This activity also, it's a for this activity also operating system is responsible. Okay, this is what we have started in the previous session. Okay. Here, the next one is the mass storage management. Okay. It's also very, very important, which is done by this is the responsibility of the operating system again. Okay. Usually, the disks use it to store the data that does not fit in the main memory. Okay, main memory, while discussing the memory hierarchy, we have discussed, right? The main memory will be fast memory and it will be of size will be small memory. Okay, so it is small, so the data which is not fit in the main memory, that will be stored in the disks. Okay, usually disks used to store the data that does not fit in the main memory. Okay, or the data that must be kept for long period of time. If you want to store something for long period of time, we will store the data in the disk, because the main memory is the volatile memory. If power goes, we'll lose the data. If you want to store the data for long time, we'll be storing the data in the disk. That is nothing but mass storage. Okay, and proper management is of central importance here, because we are storing the information for the long time, so we need to maintain the data properly. Okay, and entire speed of the computer organization hinges on the disk subsystem and its algorithms. Okay, how we are managing this mass storage, how we are managing this mass storage depends on that complete computer system, computer operation speed will be depends here. And here in this mass storage management, the operating system activities are free space management. Okay, in disk, if there is a free space, that will be managed by the operating system. Which data to be allocated there, which data to be stored there, which file should be removed from that, that will be managed by the operating system here. And storage allocation, disk scheduling, this will be done by the, these are the activities done by the operating system. We'll discuss these in detail when we will be discussing the mass storage management. Here you just remember that what are the operating system activities regarding to mass storage management. Okay, here operating system activities are free space management, storage allocation, disk scheduling. Next, some storage need not to be fast. Okay, we doesn't want every storage to be very fast, but we want more information to be stored. So that time we go for the mass storage. Okay, uh, tertiary storage includes like optical storage, magnetic tapes, and all, which will comes under this mass storage. Okay, and still must be managed. Okay, and here the which will varies between the WORM, that is write once, read many times, and read write. Okay, which will be varied between these different time terms. by this all together is called mass storage management. We'll discuss in detail about this. Write once, read many times, and read write in while discussing the mass storage management. Here you just remember the terms and remember the operating system activities with respect to mass storage management. Okay, here mass storage management, with respect to mass storage management, operating system activities are free space management, storage allocation, disk scheduling. Okay, for this disk scheduling, again we use some algorithms to do the disk scheduling and all. That we'll discuss while discussing the mass storage management. Okay, yeah. Next, performance of various levels of storage. Okay, we'll see here how the different storage will be different, distinguished. We'll be discussing how different storages are different. Okay, and movement between the levels of storage hierarchy can be explicit or implicit. Here we can see the level 1 registers, level 2 cache memory, level 3 main memory, level 4 disk storage. It is nothing but mass storage. Okay, level 4 is the mass storage. Next, here in registers, typical size will be less than 1 KB. Okay, while discussing the storage management, we have seen where the register comes at the top. Okay, from bottom to top, if you go, the size will be less. Okay, it can its registers size will be less than 1 KB, whereas cache will be greater than 16 MB. Okay, the main memory will be greater than 16 GB. Disk storage will be greater than 100 GB. Okay, and implementation technology here. Here registers will implement custom memory with multiple ports and CMOS. Okay, whereas cache will implement on chip or off chip CMOS SRAM. Okay, whereas main memory implementation technology is CMOS DRAM, and disk storage implementation technology is magnetic disk. Okay, and access time in nanoseconds. Yeah, and we discussed, right, while discussing the storage hierarchy, if you go from bottom to top, the speed will be more. Okay, fast. Here the access time will be, registers access time will be 0.25 to 0.5 nanoseconds, whereas cache memory it is 0.5 nanoseconds to 25 nanoseconds, whereas main memory access time will be 80 to 250 nanoseconds, whereas disk storage will be 5000 nanoseconds access time will be. Okay, when you come from top to bottom, it will increase, access time will increase. Okay, and bandwidth, here bandwidth for the registers is 20,000 to 1 lakh. Okay, whereas cache memory bandwidth will be 5,000 to 10,000, whereas main memory bandwidth will be 1,000 to 5,000, whereas disk storage bandwidth will be 20 to 150. And he managed by the registers will be managed by the compilers. Cache memory will be managed by the hardware. Main memory will be managed by the operating system. Disk storage also will be managed by the operating system. Okay, and backed by, like, after register will be backed by cache, and cache will be backed by main memory. Main memory will be backed by disk will be backed by CDR tape. Okay, this is the memory hierarchy. And understood, right, the difference between registers, cache, main memory, and disk storage. Okay, if you go from this side to this side, the size will be small. Okay, and if you go from this side to this side, it will be slow to access. Okay, that is the difference between registers, cache, main memory, and disk storage. Understood, right? Next, we'll see what is caching. Caching also you have studied in your computer organization. Okay, here once again we'll just see what is caching and all. Okay, it is important principle performed at many levels in the computer, like hardware level also we can perform caching, operating system level also we can perform caching, software also we can perform caching. Okay, and information in use copied from slower to the faster storage temporarily is called caching. Information in use copied from slower to the faster storage. Okay, from the slower storage to the faster storage, temporarily we'll copy, that is called caching here. Okay, a faster storage, that is nothing but the cache, is checked first to determine if the information is there. Okay, first if our operating system wants to do perform some operation, first it will check for the program will check for the information in the cache. Okay, if that information is present in the cache, then that information is used directly from the cache. Okay, if the information is not there, okay, then the data is copied to the cache and then used there. Okay, the data will be fetched from the, next we'll check in the main memory. If the data is not there in the cache, we go on check in the main memory. If it is present in the main memory, they will copy the data from main memory to the cache and then we use it. Okay, so thinking that we are going to use that later. Okay, later that same data may be used by the program, so we will store the one copy of data to the cache. Okay, so the next time the program wants the same data, so it doesn't need to go to the main memory and fetch the data. We can directly access the cache and access the data. Okay, and cache is smaller than storage being cached, and cache management important design problem. Okay, we'll discuss again this while discussing the memory management in detail. We'll discuss this caching and all. Understood, right? Whatever we have discussed, it's like copying of information in use from the slower to the faster storage temporarily is called caching. Okay, if the faster storage is checked first to determine if the information is present or not. If it information is present, then information is used directly from the caching. If the information is not present in the faster memory, that is caching, then the data is copied to the cache and then used. Okay, that's about caching. Next we'll see here migration of integer a from disk to the register. See here, integer, think that, assume that integer a we want to increment by 1. Okay, so the integer a was present in the magnetic disk. That first it will be shifted to the, transferred to the main memory, from main memory to cache memory to hardware register. Here the data of a will get modified to incremented by 1. Okay, that time the previously the cache and main and disk will be having the older data only. Okay, especially this while we are dealing with the multitasking environment, must be careful to use the most recent values. Okay, no matter where it is stored in the storage hierarchy. Okay, whether the DA is stored in the register or cache or main memory or magnetic disk, we should have the most recent value while we are dealing with multitasking environment. Not only that, while dealing with the multiprocessor environment, must provide the cache coherence in the hardware such that all CPUs will have the most recent value in their cache. Okay, if you have the most recent value, then only whatever operation we perform, that will be correct. Okay, after picking the fetching the older value, and if you do the operation, after doing the operation, the value got changed to some other value, whatever operation we have done, that will become fault, right? So especially while dealing with multitasking environment and multiprocessor environment, we should be careful and it should be updated. Most recent value should be updated first. Okay. A distributed environment situation even more complex, where be several copies of data can exit. Okay, distributed environment also, different values will be changed by different computer, that should get updated fast. Okay, that should be taken care. This is about caching. Next is IO subsystem. Okay, the one purpose of operating system is to hide the particularities of hardware devices from the user. That is the purpose of one purpose of operating system. Okay, this is also one of the responsibility of operating system, to hide the particularities of hardware device from user. Okay, for that we use the IO subsystem. Okay, IO system is responsible for memory management of IOs, including the buffering. Like buffering is nothing but storing data temporarily while it is being transferred. Okay, IO subsystem will be responsible for memory management of IO, including buffering, caching. Caching is nothing but storing parts of data in transfer, parts of storing the parts of data in faster storage for performance purpose is called caching. And spooling, the overlapping of output of one job with input of another job is called spooling. Okay. Uh, these are the responsibility of subsystem. Okay, and general device driver interfaces, this is also responsible of IO subsystem. And drivers for specific hardware devices, this is also responsible of IO subsystem. Okay, we'll discuss this again, okay, when we are discussing about the management, memory management. Next is protection and security. Complete this protection and security. We have a fifth module is there. In detail, we discussed this in the fifth module. Here we just discuss the what are the definition, what is protection, what is security, what is difference between protection and security. We'll discuss here. Okay. First one is protection. Protection means it's any mechanism for controlling access of processes or users to resources defined by the operating system. Okay, protection is any mechanism for controlling access of the processes or users to resources defined by the operating system. Something like we are protecting, controlling access of some processes, or controlling access by users to some resources. Okay, which is defined by the operating system is called protection. Protecting someone doing something, we are protecting it, that is called protection. Okay, controlling the access by unauthorized persons is called protection. Okay, next is security. Here security is nothing but it's a defense of system against internal and external attacks. Okay, we are securing the systems against some internal attacks and external attacks. Like it will be denial of service attack, worms, adding viruses. Okay, identity theft. Okay, theft of service. From these attacks, securing the system is called security. Understood, right? Difference between protection and security. Protection is controlling the access. Security is defensing of the system against the attacks is called security. Okay, and the system generally first distinguish among the users to determine who can do what. Okay, that is nothing but first the system generally identify which user is having what access permissions. Okay, so that the users will be distinguished. Okay, every user will be having the user ID and security ID. Okay, using that the system will distinguish the users. Okay, Like the user identifiers like user ID, security ID includes the name and associated number one per the user. Using that, system will distinguish which user is having what permissions and all. Okay, and user ID then associated with all files processes of that user to determine access control. Okay, and group identifier. Okay, group ID allows set of users to be defined and controls managed and then also associated with each process and files. Okay, like user ID will be having the group ID. So for a group ID is nothing but for the one set of users will be given the group ID. That complete group will be having some access. Okay, that will be identified by using that group ID. And privilege escalation. Okay, privilege escalation allows user to change to effective ID with more rights. Okay, from user may have some set of accesses. Okay, that will be he can increase it his access rights. That is called privilege escalation. Okay, we'll discuss these in detail when we are discussing about protection and security management in the module 5. Okay, understood, right? The difference between the protection and security. Next is computing environment. Whereas in traditional computing environment, we'll be having two different varieties of environments, that is office environment and home networks. Whereas in office environment, the PCs will be personal computers will be connected to the network terminals attached to a mainframe or microcomputers providing batch and time sharing. Okay, here in office environment, what will happen? Set of computers will be connected to the servers. Okay, servers will provide some computing environment for all the computers. Okay, now portals allowing the network and remote systems access to the same resources. Okay, through the network also these office computers will be connected to the network, and through the remote systems also can access this servers. Okay, that is about office environment. Whereas home networks, we use it to be a single system. Okay, will be only for the single user purpose we use the home network. Okay, then modern. Now these home networks also firewalled and networks. We can access, if it is connected to the network, we can access that home systems also through the network. Okay, next, client client server client server computing. Okay, we'll see what is client server computing here. uh, Dump terminals supplemented by a smart pcs here. Many systems now servers responding to the request generated by the clients. Okay, client server environment will be having a set of clients and server. The server programs are nothing but who will be responding to the request generated by the clients are called servers. Okay, and here we have two types of servers. One is compute server. Compute server provides an interface to the client to request the service, is called compute server. Example for this is database. Okay, uh, next is file server. File server provides interface for the clients to store and retrieve the files. It's called file server. Okay, here many of today's systems acts as a server system to satisfy the requests of the clients. Okay, many systems will act as a server system to satisfy the requests of the clients. The server is nothing but the system which provides the resources to the clients. Okay, who will execute the requests of a clients are called servers. Okay, the client missions are nothing but who will be requesting for some service by the server is called clients. Okay, uh, And here we have the server system can be classified into two forms, that is compute server and file server. This compute server provides an interface to which the client can send requests to perform some operation, some actions here. Okay. In response, the server executes the action and send back the result to the client. That is compute server. Okay. In compute server, what the client will do, it will request for some service. Okay. For that request, as a response, the server will execute that request and send the result to the client. Okay. That is called compute server. For this example is the database systems. Okay. Server running on the database that responds to the client request for the data is an example for compute server. Okay. Server will running, it will run some database that will respond to the client's request for the data. Whatever, if the client requests for some data from the database, the server will provide the data from the database to the client, is called compute server. Whereas file server systems, it provides a file system interface where the clients can create, update, read, delete the files. Okay, that is file server systems. For this, we can say example is web server that delivers files to clients running web browsers. Okay, the file server example, we can say the web servers will access a server and which will deliver the files to the clients running on the web browsers. Understood, right? This is the client server computing. Okay. You can see here clients and servers will be connected to the network. Client will request the server for some action to be performed. The server will execute that action and as a response, it will send the result to the client. Okay. That is client server environment. Next, peer-to-peer computing, where the peer-to-peer computing, it's another model of distributed system. Peer-to-peer does not distinguish clients and servers. Here, all the systems will be treated as peers, equal. Every system is a server, every system is a client. Okay, there is no client and no server. Okay, in previous one, the client server mechanism, we have one system will act as server, other systems will act as client. Client is nothing but who will be requesting for the server for some action to be performed. Okay, that is client. Server is who will execute the client's request and that will provide the service to the client, is called the server. Okay. Whereas peer-to-peer computing, there will be no distinguish between the clients and servers. Okay. Instead, all nodes are considered as peers here in this peer-to-peer computing. Okay. May each act as a client, server, or both. Okay. Some system will act as client, some system will act as server, but some systems may act as both client and server in peer-to-peer computing. Okay. Node must join to peer-to-peer network first in peer-to-peer computing. Okay. Node is nothing but a computer system. Remember that wherever if you mention the node, it is not something different. It is a computer system. Once the here in peer-to-peer computing, the system should be joined to the peer-to-peer network and register its service with the central lookup service on the network. Okay, first the system should be connected to the network and it should register its services with central lookup service on the network. Next, broadcast the request for service and respond to the request for service via discovery protocol. By using the discovery protocol, we can broadcast the request for service. In this peer-to-peer computing, all the computers are connected to the network. If one customer client wants some request Okay, it will post its request through the network, and the server system which is responsible, that will respond for that request, and that will execute that request, and it provides the services. That is by using the discovery protocol. Okay, this will discuss later in detail. Next one is web based computing. Web based computing, web has become more ubiquitous nowadays, and PC's most prevalent devices for web computing nowadays. Okay, more devices become network to allow web accesses. Okay, where the internet is growing very huge, the boom has come for this web-based computing. Okay, here web-based is nothing but computers are connected through the internet, web. Okay, it's a new category of devices to manage web traffic among the similar services like load balancers we use. Using this technology, we'll balance the load on the web. Okay, and use of operating systems like Windows 95 client side have evolved to the Linux and Windows XP, which can be clients and servers here in the web-based computing. Okay, here web-based computing leads to the more access by the wider varieties of devices other than the PCs and workstations, PDAs and cell phones. Okay, uh, user will interact through the web browser by using the HTTP protocol. User will interact to the web server. Okay, web server will provide the whatever, it will run the applications and respond to the whatever request he had user had generated through the web browser. Okay, that will be served by the web server in this web based computing. Web computing has increased the emphasis on networking. Okay, so the web based computing has given rise to new category of devices called load balancers, which distribute the network connections among the pool of similar servers. Okay, this is nothing but web computing.